All right, class. So we had a big lecture last time and I left you with a take-home problem. Hopefully you did this. Let's go over this take-home problem. So again, whenever we're talking about this grams to moles to molecules and atoms conversion, one thing I want you to write down every time, write down the chart. I am really proud of this chart. I want you to use it all the time. So grams can go back and forth to moles, right? And you can also go from moles to atoms or molecules depending on what we have, right? Or ions. And to go from gram to moles or moles to gram, what do we need? We need molecular weight. And go from moles to atoms and molecules and ions, or the other way around, we need Avogadro's number. So far so good? Okay. Now in this problem, we're going to write down what's given to us. And on the other thing that we said, I'm going to add one more thing, that when we have mole, the other thing that we can do over here, we can do a hashtag mole ratio, right? We can do a hashtag mole ratio when we are at moles. Okay, so I want you to have this in front of you as we're doing practice problem. So let's go write down what's given to us. What's given to us is 8.0 times 10 to the 21st. Atoms of calcium. That's what's given to us. And what I want is grams of calcium phosphate. So atoms are given to me. I want grams. You know that you can't jump. You have to go atoms to moles and moles to grams. Then you go atoms to moles and moles to grams. Yeah, I can't jump. We know that. The other thing that we need to pay attention to is that they give you calcium, but they ask you for calcium phosphate. We talked about this last time. Every time they give you one thing, but they ask for something else, what do we need to do? Hashtag mole ratio. Don't forget, you have to use the mole ratio. I forgot the hashtag over here. You have to do the mole ratio, right? Because they give you one thing, but they ask for something else. We can get to what we want using the mole ratio. Okay, so now, my plan is to go from atoms to moles, do the mole ratio to get to what I want, and then go from moles to gram. Good plan? I like it. So the first thing we're going to do, we're going to go again, atoms to moles, do a mole ratio to get to what we want, and then go from moles to grams. Okay, I have atoms of calcium. I don't want atoms, so atoms has to go on the bottom. Okay. Now what I want is moles. Mole have to go on top. Now how do I go from atoms to moles? Avogadro's number. And I keep repeating this, that the Avogadro's number is for 1 mole. 1 mole is 6.02 times 10 to the 23rd. Avogadro's number is always for 1 mole. So far so good? Okay. And this was mole of calcium. So what I end up doing, I converted atoms of calcium to moles of calcium. Again, I know that I don't want calcium. I want calcium phosphate. I'm at mole right now. Because I'm at mole right now, I can do a mole ratio, right? I can do a mole ratio. Okay, and again, the atoms cancel out. I have moles. Now that I'm at moles, I can do a mole ratio. Now, I don't want the moles of calcium. That's not what I'm interested in. What I want is the moles of calcium phosphate. Okay, so what I want is the moles of calcium phosphate. So I have to do a mole ratio. Now, what is the mole ratio? In 1 calcium phosphate, how many calcium do you have? You have 3 calcium. So in 1 of this compound, I have 3 moles of calcium. Okay. Now this is great because moles of calcium cancels out. What I end up with, which is what I wanted, is moles of calcium phosphate. So I was able to do a mole ratio and get to what I want, which is calcium phosphate. Okay. Now the last thing to do, now that I'm here, I have to go to grams because they ask you for grams. So the last part is we have to go from moles to grams. Okay, how do I do that? Again, molecular weight, 1 moles of calcium phosphate is 310 grams. So then the moles can cancel out. I end up with grams of calcium phosphate. You guys feeling okay about this? Okay, let's go over it one more time. The same thing as before. I have atoms. I'm trying to go to grams. So I have to go atoms to moles and moles to grams. You know this. We've done this so many times. You got this down. And the only other thing to worry about in this problem is that I give you calcium, but I ask for calcium phosphate. You notice every time I give you one thing, but I ask for something else, what do you have to use? Hashtag mole ratio. You gotta use mole ratio because given calcium, 1 calcium phosphate. So convert atoms to moles. Now that I'm at moles, I can do a mole ratio. I do a mole ratio in one of these compounds. It has 3 calcium. Once I convert to mole ratio, then I'm going to go back moles to grams. Yeah? Okay. Now, my final answer, before I put a final answer in, how many sig fig? This one over here is 2 sig fig, right? Sig fig, you probably agree with that. This is only 2 sig fig. This and this and this, they don't count in sig fig because those are conversion, right? They're exact number. They're not going to count. These don't count. These don't count as I'm doing sig fig. Okay, now, again, don't forget the math. You're going to multiply everything on top, divide by the bottom. So 8.0 times 10 to the 21st times 1 times 1 times 310 divided by 6.02 times 10 to the 23rd divided by 3. Now, here's the key. And if you don't do this, you're not going to get the right answer in your calculator. Don't forget to put a parentheses around this. If you don't put a parentheses around this, your calculator is going to divide by 6.02 and then multiply by 10 to the 23rd. But everything has to be divided. Okay, so don't forget to put a parentheses around it. All right, 2 sig fig is my final answer. My final answer is going to be 1.4 grams. This was a big problem. This is a big practice problem. Hopefully you guys got this down. All right, our next topic now. So hopefully you got this down. Our next topic is chemical equation and stoichiometry. So next thing we're going to talk about stoichiometry. Now, what is a stoichiometry? The best way to think about a stoichiometry is cooking. And I don't cook and I'm really bad at it. So I have really bad examples for this, but just go with it. Let's say you need to cook some kind of dinner, right? What you need to go and buy ingredients, right? So for example, you say, I have 5 guests. So I need to make enough food to feed 5 people. Then you go and you buy enough ingredients to feed 5 people. Or if I have 2 bags of pasta, how many people can I feed? So that's stoichiometry, is cooking an ingredients and figuring out how much ingredients you need to make this food. Or if you have this many ingredients, how much food can you make? So far so good? Okay. So always think about cooking as we are doing stoichiometry. Again, I have this many ingredients, how much food can I make? Or if I want this much food, how much ingredients do I need to buy? Now, I want to write down a chemical equation. Iron 3 sulfide plus O2 gas going to iron oxide plus SO2. Okay? What I need you to do, I want you to balance this equation. I want you to balance this equation. Okay? Let's balance it together. I have 1 only Fe over there, so I'm going to put a 2 over here. So then I have 2 Fe, 2 Fe. I have 3 sulfur, I have 1 sulfur, so I'm going to add a 3 over here. Okay? Always balance oxygen last, otherwise you're going to go crazy. Always balance oxygen last. Then I have 2 oxygen here. I have 2, 3 times 2 is 6. So I have 6 over here, 2 over here. That would be 8 together. So 2 over here. 3 times 2 is 6 over here. 2 plus 6 is 8. Oh boy, sometimes my math. So I have 2 over here. So I would put a 4 here. So far so good. Okay. Now to balance it, we put down coefficients. I mentioned this a couple lectures ago, which seems so far ago, I said, what do coefficients mean? And I said coefficients are the mole ratio. Coefficients are the mole ratio. And I need you to remember that coefficients are the mole ratio. Coefficients are the mole ratio. Coefficients are the mole ratio. So what is the mole ratio between iron 3 sulfide and O2? What's the mole ratio between these two? What do you think? I'm going to come over here. So this has a 1, this has a 4. So the mole ratio would be 1 to 4 mole ratio. So that's what coefficients means. Coefficients, when you put it in your balance equation, those are the mole ratio. Those are the ratio that you need to make something or to do something. So don't forget, those are the mole ratio. Are we good so far? Okay. So far so good. Good job. Now, I'm going to put up our first practice problem to do. Okay, here's the next problem. And I give you an equation. Before you even read the question, let's balance this out, right? You know you always have to balance it. So I have one aluminum, I have one aluminum, I have one Cl, I have 3 Cl. So, and then, let's see. Then that means, what would I need to do? If I put a 3 over here, would that work? Let's see, then I'll be 3 Cl, and I have 3 Cl matches up with this. Now, how about hydrogen? Ooh, I have 2 hydrogen here, I have 3 hydrogen here. That wouldn't quite work out. That wouldn't quite work out. So I can't do that because then my hydrogen are not going to balance out. So what do I need to do? I need to probably add a 3 over here, okay? So I would have 6 hydrogen. I add a 6 over here, so I have 6 hydrogen. And add a 2 over here, so now it's balanced with aluminum. I went a little fast because we've done balancing a lot. So hopefully you guys are getting the hang of it. Again, sometimes you have to keep going back to be able to get the balancing that you want, to get the right balancing. Alright, so I balanced the chemical equation. That's good. I have coefficients, and I know coefficients means the mole ratios. Coefficients are the mole ratio. I said how many moles of H2 are produced when 4.6 moles of aluminum is reacted. Okay, so I have 4.6 moles of aluminum. So I have 4.6 moles of aluminum. And I want to know, when I have 4.6 moles of aluminum, how many moles of H2 is produced. Now, without knowing anything, when you look at this problem, here's how I want you to look at it. I want you to look at it and say, okay, what's given to me is aluminum. What they asked me for is H2. They give me one thing, they ask for something else. Every time they give me one thing, they ask for something else. What do I need to use? Mole ratio, right? I need to use mole ratio. So I don't want the moles of aluminum is going to go down here. What do I want? I want moles of H2 is going to go on top. Now, how do I know the ratio? The coefficients are the mole ratio. Coefficients are the mole ratio. So if I look over here, I have 3H2 for 2 aluminum. The coefficients are the mole ratio. Okay, so 4.6 times 3 divided by 2, it will be 6.9 moles of H2 is going to be produced. Again, the way to look at this is that I have 4.6 moles of aluminum, right? How much H2 can I make? I give you one thing, I ask for something else. You have to do the mole ratio. You have to do the mole ratio to figure out how much of the other one you are going to produce. So far, so good. Okay. Are you ready for our next practice problem? Yes, let's do it. We're going to keep doing practice problem until you get this concept down. Here's the next problem. Okay. How many grams of water is needed to make 1.00 grams of O2? Do you see the similarity between cooking and stoichiometry? Hopefully you do, right? So here, I want to know I want to make 1.00 grams of O2, and I'm wondering how much water do I need? How many grams of water do I need to have in order to make 1.00 grams of O2? It's the same thing, right? You want to know how much ingredients you need to buy if you want to make this much food. Now, the thing to kind of look at over here is that what is given to you is O2. What they ask you for, what you want, is H2. So every time, and I want you to notice right up, we go, okay, what is given to me is O2. What I want is H2O. Given to me, want, are different. What do I need to do? I know this is going to be a mole ratio problem, okay? Now, you are going to put down what's given to you first. What's given to us is 1.00 grams of O2. Now, O2 is given to me, but I want H2O. So I need to do mole ratio, but I need moles in order to do a mole ratio. Do you have moles right now? You do not. You have grams. Well, can you figure out moles from grams? Yes, you can, using molecular weight. So I don't want grams, I want moles, and I want moles so I can end up using a mole ratio. Now, moles of O2, okay? Now, I need a moles of O2. So I know that 1 mole of O2 is 32.0 grams, okay? So what I ended up doing, I ended up using molecular weight to convert grams to moles. You guys are following me so far? Now that I have moles, I go, moles of O2 is not what I wanted. What I really wanted was moles of H2O. Moles of O2 was not what I wanted. What I wanted was moles of H2O. Okay, how do I figure out this mole ratio? Coefficients are the mole ratio. Coefficients are the mole ratio. I want you to repeat that right now. Coefficients are the mole ratio. So I already balanced this equation for you. I've been a little nice right now. If I look over here, this is 2 and this is just 1. So the mole ratio is 2 to 1. So the moles of O2 can cancel out and I end up with moles of H2O. That's what I want. I'm almost there. If they had just asked for moles, I will be done, but they asked for grams. So now what I have to do, I have to convert moles to grams. How do I do that? I know how to do that. Molecular weight. So moles of H2O has to cancel out. I need grams of H2O. I know how to do that. Molecular weight. 1 mole of water is 18.0 grams. So the moles cancel out and I end up with grams of water, which is what I wanted. Okay. Did you guys follow that? Yeah? All right. Now, again, I need mole, right? But I need to do a mole ratio. But before I can do a mole ratio, I need to get to moles. And usually grams doesn't really get you far in chemistry. What you really want is moles. Now, if you do this, the answer that you get is 1.125 grams. Now, how many sig fig do I need? I'm going to come over here. You notice this is 3 sig fig, right? 1.00 is 3 sig fig. Now, I don't care about the sig fig here, here, or here. These are all conversion, right? Molecular weight, you didn't measure that. These are all conversion. This is what we measured. This is the sig fig that matters, and that has 3 sig fig. Okay, now the reason I wanted to go over this because this has a 5, and sometimes, so what do you guys think right now? So the answer is 1.125, right? And I want it to be only 3 sig fig. 1.125, I need it to be only 3 sig fig. But my last number is 5, okay? So remember what we said. If you have 5, you have to look at the number before. If the number before is an even, you round down. If the number before is odd, you round up. Okay, so this 2 is going to be even, so my number would be 1.12 grams. Yeah, okay. So for example, if this number was an odd number, then it would have been 1.15 3, but I have to round down because this is 5. Not many people follow this 5 odd or even rule, but I just wanted to put it out there one more time since we had gone over it in the past. So far so good. Okay, let's do one more practice problem and then I think you're going to be set with the stoichiometry. One more. Alright, pause me, do this problem, and then we're going to go over it together. So what you have here, what's given to you, is 100 grams of H2. I'm going to write down 100.0 grams of H2 is given to you. You agree? Okay. Now, how many grams of ammonia can be made? So when I read this, I go, okay, hold on a second. I know what they're trying to do here. Because what they're giving me is what? Is H2, right? So H2 is given. I have 100 grams of H2, but what they want and what they're asking me is ammonia. They give me one thing, they ask for something else. Every time they give me one thing, they ask for something else. What do I have to do? I have to use mole ratio, right? I have to use mole ratio because they give me one thing, they want something else. I need to use hashtag mole ratio. Yeah, so you see that you go with mole ratio. Well, before I use mole ratio, I need to convert this to moles. I can't use mole ratio if I don't have moles. So I'm going to convert gram to moles and then do a mole ratio. So to do that, again, grams goes here, moles of H2 goes on top, because then I can cancel out the grams, right? Then I can cancel out the grams. How do I go from grams to moles? Molecular weight. 1 mole of hydrogen is 2.016. Okay. Again, I'm trying to spend a little more time to remember the rule of thumb. To be really correct is that this is 4 sig fig, so the molecular weight should also match that. Sometimes I don't follow that rule myself, but I'm going to try to be a little bit better at it. Okay, and also sometimes the periodic table that you have might be different, might have a slightly different molar masses on there. Okay, so as sometimes there are small differences, I just want you to pay attention to that. But the rule of thumb is has 4 sig fig, right? This has 4 sig fig, 1, 2, 3, 4, and this one should match that. This one should match the sig fig because this is the exact number. This is not something you measure. You can just take it from the periodic table, but it should match what we measured, which is 4 sig fig. In this problem, we are bound by 4 sig fig. Okay. So the grams cancel out, then I have moles, but I don't want moles of H2. Moles of H2 is going to go here. What I want is moles of ammonia. So what I want is moles of ammonia, but I have moles of H2. I have to do a mole ratio. I have to do a mole ratio so the moles of H2 can cancel out and I can end up having ammonia. Now remember we said coefficients are the mole ratio. Coefficients are the mole ratio. Coefficients are the mole ratio. Okay. I'm going to come over here. 2 ammonia for 3 H2. So coefficients and a mole ratio. So now I have ammonia, which is what I want. Now the last part of this is what? I will need to convert moles to grams. So I have 1 mole of ammonia for molecular weight. So again, you have to go back to the molecular weight. It would be 17.03. Okay, you guys are following me so far? Again, and now the moles can, I did not just do that. The moles can cancel out. I end up with grams. All right, let's go over this one more time. So what they're giving me is H2. What they want is ammonia. Every time they give me one thing, they want something else. I have to do hashtag mole ratio. I have grams. I need to convert it to moles in order to do a mole ratio, right? So I'm going to go grams to moles. And how do I go from gram to moles? Molecular weight. And then I do a mole ratio once I have moles. So once I have moles, then I can do a mole ratio. Now, how do I do the mole ratio? Coefficients are the mole ratio. So you look at the balanced equation. It has to be balanced. You look at a balanced equation and you're going to do a mole ratio. So we did a mole ratio, so I cancel the moles of H2. I end up getting the moles of ammonia, which is what I want, okay? So now I have that, but the question asked me for grams. If they had asked me for moles, I would be done. They asked me for grams. So what I'm going to do next, I'm going to again convert moles back to gram. How do I convert moles to gram? I have to use molecular weight. I have to use a molecular weight. You guys are good so far? Okay. And now sig fig always matter. I'm bound to 4 sig fig. So my final answer should also have 4 sig fig. So you time multiply everything on top, divide by the bottom. What I end up getting is 564.8 grams of ammonia. Now, one thing I want you to pay attention to is that sometimes we may use a different periodic table that may have slightly different molecular masses and molar masses. But the rule is, whatever in this problem, I'm bound to 4 sig fig, so my molecular weight should match that, because technically this is the exact number, is a conversion, right? So we would try to match this to that. And sometimes as I'm doing problems, I may not follow my own rule, but this is a correct way of doing things. Basically do as I say, not as I do sometimes. Nice job. Next time we're going to continue with this, but make sure you get this down. Before we move on to the next part. Beautiful job. I will talk to you guys next time.